I am going to be referring to this document. Okay? I've already put some important facts on the board, and perfect squares after 1 are 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Okay? All right, so we're on page 1 of this document. Illustrations. Okay, I'm following this loosely. Illustrations. Square root of negative 4. I can split this up into the square root of negative 1 times 4, which would split up into the square root of negative 1 times square root of 4. Square root of negative 1 is I. Square root of 4 is 4, which square root of 4 is 2 times the I. Okay? Square root of negative 9. I'll go ahead and skip the equivalent of this step. Factor out the I, and I'll have the square root of 9, which gives me 3 times I. Okay? Similarly, square root of negative 16 is 4i. Square root of negative 25 is 5i, etc. Okay? The square roots of negative numbers are so-called imaginary or non-real. The reason they're called imaginary numbers, real numbers, non-real numbers, etc., is because in the 1500s, it was discovered that for our number system to work the way that it does, negative numbers had to have square roots. The problem is, if you square a negative number, it's positive. You square a positive number, it's positive. There are no numbers, no real numbers squared that give you a negative number. So they knew they had to exist, but they had no appearances in nature, so they called them imaginary. It turns out they have very real uses in electrical engineering. So moving on. So note, beware. Okay, so I have here beware on page 1. Negative square root of 64 would just be negative 8 versus square root of negative 64. Well, it's square root of a negative number, so it's going to be imaginary, and square root of 64 is 8. But cube roots of negative numbers are negative. Okay? All right, example 1. I'm not going to be doing all of these. Example 1 is a square root of negative 17. Take out the I, and it leaves me a square root of 17. Example 2. I got the square root of negative 10. Factor out the square root of I. Or square root of negative 1 is an I, and I have the square root of 10. Now 10 is not divisible by any of those lists, the numbers in that list, so that's introduced. The square root of 10 will stay as is. That's different from the square root of negative 20. I'll factor out the I, and I'll get the square root of 20. But 20 is divisible by 4. So I, square root of 4, square root of 5. Square root of 4 is 2, so 2 times I, square root of 5. All right, so that was how you would reduce radicals. So now I'm going to move on to page 2. Okay, page 2. Add, subtract. So example 1, 3 plus 5i plus negative 7 plus 9i. Here what we're going to do is we simply add, this is what's called the real component, this is the imaginary component. Real component, imaginary component. We add the real components. 3 plus negative 7 is negative 4. Then we add the i's. 5 i's plus 9 i's is 14 i's. That's all there is to it. Okay? For example 2, if I have 6 minus 2i minus 1 plus 7i, you'll distribute the negative through, giving me 6 minus 2i minus 1 minus 7i, which gives me negative, that gives me 5. Minus 2 i's take away 7 i's is minus 9 i's. Okay? Example 3. Negative 4 minus I minus negative 3 minus 8i. Distribute. Negative 4 minus I plus 3 plus 8i. So that's negative 1. If I'm down an I against 8 i's, that puts me up 7 i's. Okay? And example 4. 5 minus 2i minus 4 minus 3i. Distribute and change the signs. 5 minus 2i minus 4 plus 3i. 1 plus a single I. All right, page 3. Page 3. Multiply. Example 1. 5 times 4 minus 3i. That's a basic distributive property situation. 20 minus 15i. Okay? Example 2 is where things start to get more interesting. 5i times 8 minus 2i. Now remember, folks, I squared, recall, I squared is negative 1. That's very important here. So this is going to be 40i minus 10i squared. But we don't leave it like that. We replace I squared with negative 1. Okay? Which gives me 40 plus 40i plus 10. And then you put the real component first, the imaginary component second. Okay? Moving on to example 4. Five plus 2i, 6 minus I. Treat these like two terms, so that's a binomial problem. So 5 times 6 is 30, minus 5i, plus 12i, minus 2i squared. Okay? So this will be 30. This will combine as 13 i's. I'm sorry, this will combine as 7 i's. And then minus 2 times negative 1. So 30 plus 7i plus 2. 32 plus 7i. Page 4. Example 6. Page 4, example 6. 5 plus 2i, 5 minus 2i. F, O, I, and L. So 25 minus 10i plus 10i minus 4i squared. Okay? These combine as 0. So I have 25 minus 4 times negative 1. And 25 plus 4 is 29. Okay? These are what are called conjugates. Conjugates. Shortcut. So, or I could have done shortcut for conjugates. This is the conjugate of this. This is the conjugate of this. The only difference between the two of them is a sign in the middle. So 5 plus 2i, 5 minus 2i. All you would need to do is the first and the last. Okay, but you can only do that for conjugates. Okay, you can only do that for conjugates. For the others, you have to do the whole FOIL method. Okay, this is not available here. Can do for conjugates, no can do for this. Okay? All right. Moving on to page 5. Page 5. Simplifying fractions. Okay? So example 1. 3 plus 2i, 6 minus I. Do. So 3 plus 2i over 6 minus I. What you do is you multiply top and bottom by the conjugate of the denominator. Pause this if you want to. So this will be 6 plus I, 6 plus I. That's what we use conjugates for. So the top, F, O, I, L. So that's going to be 18 plus 3i plus 12i plus 2i squared. So that gives me 18 plus 15i plus 2 times negative 1. 18 plus 15i minus 2 gives me 16 plus 15i. Now, if they're just conjugates, all you have to do here is multiply 6 times 6, that's 36, minus I squared. 36 minus negative 1 is 36 plus 1, which is 37. So, top over bottom gives me 16 37ths plus 15i over 37. Factor I out of fraction. Factor the I out of the fraction. So you should have 16 37ths plus 15 37ths times the I. And that is considered the simplified form of this type of problem. Okay, page 6. Powers of I. Powers of I. So, I the 0th is 1, I the 1st is itself, I squared is negative 1, and I cubed is negative I. Okay? If you want to pause the video here, you can. There's a pattern. Here's what to do. Divide the exponent by 4, look at the remainder, and match with the remainder and the exponent in the cycle. So for instance, example 1, I to the 13th. Do. Divide by 4. 4 goes into 13 3 times. 4 times 3 is 12. That gives me 3, remainder 1. That's the important number here. I to the 1st, I to the 1st is I. So I to the 13th is also I. Okay, example 2. I to the 32nd. Do. 32 divided by 4. 4 goes into 32 8 times. I get a remainder 0. I to the 0th is 1, so I to the 32nd is also 1. Okay? Example 3. I to the 27th. Do. 27 divided by 4. 4 goes into 27 6 times. Gives me 6 times 4 is 24. It's 6 remainder 3. I cubed is negative I. So I the 27th is also negative I. Okay? Example 4. I the 42nd. Do. 42 divided by 4. 4 goes into 40 10 times. 40 remainder 2. So I squared is negative 1. So I to the 42nd is also negative 1. Okay. Page 7. Page 7, example 2. I to the negative 147th equals, well, let me go ahead and do it. Do. This is equivalent to 1 over I to the positive 147th. Do. So we're going to first start with first. I to the 147th will be 147 divided by, so I'll do this alone first. So 4 goes into 14 3 times. 4 goes into 27 6 times. 6 times 4 is 24. 36 remainder 3. I cubed is negative I. So I to the 147th is also negative I. So let's finish the job. 1 over negative I. Multiply by denominator conjugate. So 1 over negative i's conjugate would be 0 minus i's conjugate would be 0 plus I. like so. So that will give me negative I squared over, or under, that'll give me negative I squared under 1I, which is just I. Well, I'll just do it this way for this time. 1I. So that will give me I over negative 1, which is I over 1, which is just I. Okay, and this is where I will stop.